Hello, let us try to do this example. So there is an example on your screen. We are going to try and do it together. So the example says, given A, so we have matrix A equals 4, 3, 4, 3, negative 1, negative 2, and C equals 3, 7, negative 1, negative 2. Then you're being told, find B such that A squared plus B equals the inverse of C. So you're being told here to find B, given that A squared plus B equals to the inverse of C. Now, that sign usually shows the inverse. So how can we work out that? So first of all, we are going to work out the square of A. Now, the square of A, we are going to say here, square of A is like multiplying A by itself. So I'm going to come here, say 4, 3, negative 1, negative 2. Then 4, 3, negative 1, negative 2. Now, what you have to know is that we did talk about multiplication of matrices. Remember, we said that when you're multiplying a matrix, you usually consider the row and the column. So in this case, this is the row and this is the column. So I'm going to multiply this first row with the first column, the first row with the second column. Then I come to the second row with the first column, second row with the second column. So let us do that. 4 multiplied by 4, that is 16, plus 3 multiplied by negative 1, that is negative 3. Then 4 multiplied by 3, that one is 12, plus 3 multiplied by negative 2, that one is negative 6. Then negative 1 multiplied by, now we are done with the first column, and the first row, the first column and the second row. So we go to the second column and the first row, the second column and the second row. So the second column and the first row is going to be negative 1 multiplied by 4, that is going to be negative 4, plus then negative 2 multiplied by negative 1, that is 2. Then we go to negative 1 multiplied by 3, that one is negative 3, plus negative 2 multiplied by negative 2, that one is 4. Then we are going to add to get A squared, whereby A squared is going to be equals to 16 plus negative 3, that one is 13. Then 12 plus negative 6, that one is 6. Then negative 4 plus 2, that one is negative 2. Then negative 3 plus 4, that one is negative 1. So that is going to be our A squared. So we've gotten the A squared. Now we need to get the inverse of C. So the inverse of C, my C is equal to 3, 7, negative 1, negative 2. So first of all, we are going to get the determinant, whereby the determinant, I said, we take the leading diagonal, we subtract the product of the leading diagonal, and then we subtract the product of the end diagonal. The product of the leading diagonal is going to be 3 multiplied by negative 2, subtract the product of the end diagonal, which is 7 multiplied by negative 1. Whereby, what am I going to get there? I'm going to get there negative 6, subtract 7 multiplied by negative 1, that is going to be negative 7. Whereby, I'm going to get my inverse there as 1, because negative 6 plus 7, that one is 1. The inverse of 1 is just 1. Now, let us now get the inverse of the matrix. Now, the inverse of the matrix, remember we said that the inverse of the matrix, first of all, the leading diagonal, you change their position. So it means that I'm going to have here negative 2, and then the end diagonal, you change their sign. So because 7 is a positive, it is going to be a negative 7. And then negative 1, this one is a negative, it is going to be a positive 1. Then we are going to have there 3, because we change the position and then we change the sign of that. So that is what we are going to have as our inverse of the matrix. When you multiply by the inverse of the determinant, which is 1, I'm just going to remain with negative 2, 7, 1, 3. So the inverse of C is that. Once we've gotten that, now we can get the value of B. Remember, you are told that B, A squared plus B equals the inverse of C. If I want to get B, I can take this A squared to the other side, it will be a negative. So I'll have here B being equals to the inverse of C minus A squared. Which means the inverse of C, my inverse of C is negative 2, negative 7, 1, 3. Then minus A squared. A squared is 13, 6. 6, negative 2, negative 1, negative 2, negative 1. Then now we combine them using that subtraction. Negative 2 minus 13, that is going to be negative 15. Then negative 7 minus 6, that is going to be negative 13. Then 1 minus negative 2, that is going to be 3. Then 3 minus negative 1, that is going to be 4. And this is our matrix B. That's how we work out matrix B. Hello, today I want us to try to do this question here. You're being told, find the value of x given that, now we have the question 2x minus 1, 1, x squared, 1. Whereby you're being told this one is a singular matrix. Singular matrix. Now, how are you going to get the value of x? You're being told to solve for x. Number one thing you have to know, singular matrix, their determinant is 0. And you know, for us to get the determinant is the difference between the product of the lead diagonal and the product of the end diagonal. So let us get the product of the lead diagonal, that is the product of 1 multiplied by 2x minus 1 minus the end diagonal, which is x squared minus 1. Then this one is going to give us the what? The determinant. So let us multiply that. I'm going to have there 2x minus 1 minus, that is going to be x squared minus 1 equals 0. Remember we said that the determinant of a singular matrix is 0. That one is a quadratic equation. Let us arrange it in form of ax squared plus bx plus c equals 0. So I'm going to begin with negative x squared, then plus 2x minus 1 equals 0. So I don't want to work with a negative there. My initial value, my initial coefficient, I don't want to work with it when it is a negative. So I'm going to divide everything by negative 1 to make it a positive. So negative 1, negative 1, negative 1. So negative 1 divided by that, I'm going to get positive x squared. Then negative and positive a here gives me a negative 2x. Then that is going to be positive 1 equals 0. So let us solve that using the quadratic equation formula, whereby I know quadratic equation formula states that x equals to minus b plus or minus the square root of b squared minus 4ac over 2a. Let us get the value of x using that. So this one is going to be my a, this one is going to be my b, this one is going to be my c. So let us replace them in our formula. So x equals negative b. So because my b is negative, that negative and the negative for the b are going to form a positive. So I'm going to have my negative b as 2 plus or minus the square root of b squared, which is 2 squared minus 4 multiplied by a. My a is 1. Then multiplied by c. My c is also positive 1 over 2 into 1. Whereby what am I going to have as the value of x? That is going to be 2 plus or minus the square root. 2 squared, that is going to be 4 minus that is also going to be 4 divided by 2. Whereby I'm going to have there 2 plus or minus the square root of 0. 4 minus 4, that is going to be 0 over 2. Whereby what am I going to have there? I'm going to have there 2 plus or minus 0 over 2. So what are the values of x? The value of x is either 2 plus 0, which is 2, divided by 2, that one is 1, or 2 minus 0, that is 0, divided by 2, that is 1. So the value of x here is 1. And that is how we get the value of x in that.